we will discuss filters. The content of this topic are introduction, applications, difference between ideal and practical filter, properties of filter, relationship between decibel and Napier, classification of filter. What is filter? A filter is an electrical network that can transmit signals within a specific frequency range, called as passband, and other frequency band where the signals are suppressed is called as attenuation band or stop band. The frequency that separates these two bands, that is passband and stop band, is known as cutoff frequency. Filter is classified into two types, passive filter and active filter. Passive filter consists of only passive elements such as resistor, inductor and capacitor. A filter is said to be active filter if it contains active elements such as transistors and op-amp. Filters are widely used in electronics and telecommunication, radio, television, audio recording, radar, control systems, music synthesis, image processing and computer graphics. Then difference between ideal and practical filter. What is ideal filter? An ideal filter would transmit signals under the passband frequencies without attenuation and completely suppress the signal with attenuation band of frequencies with a sharp cutoff profile. Then what is practical filters? Practical filters do not ideally transmit the signal under passband due to absorption, reflection or due to other losses. This results in loss of signal power. Also, the filter do not completely suppress the signal in attenuation or stop bands. Then properties of filter. The passive filter has following properties: characteristics impedance, passband characteristics and cutoff frequency characteristics. These three characteristics we will briefly discuss in classification of filter. Then what is the relationship between decibel and Napier? The attenuation of wave filter can be expressed in decibels or Napiers. What is Napier? Napier is defined as the natural logarithm of the ratio of input voltage or input current to output voltage or output current, provided that the network is properly terminated in its characteristics impedance. Here the two-port network is shown, whereas V1 and I1 are the input voltage and input current, and V2 and I2 are the output voltage and output current. So here what is Napier? Napier, N is equal to natural logarithm of the ratio between input voltage to the output voltage, that is log E V1 by V2 or log of E I1 by I2. A Napier can also be expressed in the terms of input power P1 and output power P2 as N is equal to 1 by 2 log E P1 by P2. A decibel is defined as 10 times the common logarithms of the ratio of input power to output power. Decibel D is equal to 10 log Western P1 by P2. The decibel can be expressed in terms of ratio of input voltage or input current and the output voltage or output current. That is, D is equal to 20 log base 10 V1 by V2 is equal to 20 log base 10 I1 by I2. 1 decibel is equal to 0.115 Nepper. Classification of filter. Filter is briefly classified into two factors. The first one, depending upon the relationship between the ohm impedance, and second, depending upon frequency characteristics. So, depending upon the relation between the ohm impedances, it is classified into two types: constant K type or prototype filter and second M derived filter. And depending upon frequency characteristics, it is classified into four types: low pass filter, high pass filter, band pass filter and band stop filter or band elimination filter. What is constant K type filter? Students, in your syllabus only constant K type filter is there, M derived filter is not there. So we discuss constant K type filter. In constant K filter, the relationship between series arm and shunt arm impedance is such that Z1 into Z2 is equal to R0 square, that equal to K, where Z1 is the series arm impedance and Z2 is the shunt arm impedance, where R0 is a real number and independent of frequency, called as design impedance. Any filter which satisfies this relation is called as constant K filter. Then come to the disadvantages of constant K type filter. Constant K type filter have the first disadvantages: the attenuation does not increase rapidly beyond cutoff frequencies. Second, characteristics impedance varies widely in the pass band from the desired value, and these two disadvantages are overcome by using M derived filter. Then come to the constant K low pass filter. Constant K low pass filter has series impedance as inductance and shunt impedance as capacitance. The first figure shows the T configuration of low pass filter and the second figure shows the pi configuration of low pass filter. Here the third figure shows the low pass filter attenuation characteristics. It shows the relationship between gain and frequency. Here the vertical dotted line shows the cutoff frequency. From this curve, it is very clear that low pass filter passes the signal below cutoff frequency and stop or attenuates the signal above the cutoff frequency. Next, high pass filter. High pass filter, it is the reverse of low pass filter. High pass filter, it has shunt arm as inductance and series arm as capacitance. The first figure shows the T configuration of high pass filter and the second figure shows the pi configuration of high pass filter. The third figure it shows the high pass filter characteristics. From this graph it is very clear that the high pass filter it passes the signal above cutoff frequency and attenuates all the signal below cutoff frequency. Then come to the constant K bandpass filter. Constant K bandpass filter it is the combination of low pass and high pass filter. Here the series arm impedance is the series combination of inductor and capacitor, and shunt arm impedance is the parallel combination of inductor and capacitor. The first figure shows the T configuration and second figure shows the pi configuration of bandpass filter. The third figure shows the bandpass filter characteristics. It is very clear that from this figure it is very clear that bandpass filter passes the signal within the frequency range f2 to f1, where f2 is the lower cutoff frequency and f1 is the higher cutoff frequency, and it attenuates the signal below and above this frequency. Then constant K band stop filter or constant K band elimination filter. It is the reverse of constant K band pass filter. It series arm impedance are the parallel combination of inductor and capacitor, and shunt arm impedances are the series combination of inductor and capacitor. The first figure shows the T configuration and second figure shows the pi configuration of band stop filter. The third figure shows the band pass band stop filter characteristics or gain versus frequency characteristics. From this figure it is very clear that it passes the signal below and above the frequency range f1 and f2, and within this frequency range f1 to f2 it attenuates the signal. So students, in this topic you have learned what is filter, what are the application of filter, what is the relationship between decibel and Napier, and the classification of filter.